Hello, I'm Peter Milliken, and as you can see from this slide, I'm a member of the faculties of Computer Science and Philosophy at Oxford, and I'm going to be talking to you about the links between the two subjects. They go back all the way to Alan Turing, the inventor of computer science, who you can see here. There's lots to say, and I've got a handout with 72 slides, which you can get in a way that I'll show you shortly. I've divided it into 6 sections, and I'm going to start by just talking briefly about the last 3 sections, and then come back to the first 3. So the last 3 sections are 3 topics on thinking machines, and the first of them discusses, this is section 4, discusses a topic that was of great interest to Alan Turing himself, namely, can we properly call a machine or a software intelligent? He thought we could and argued for it. And in slides 39 to 56, I discuss that and give you some links to explore. So I hope you'll do that and find that interesting. Section 5, Artificial Intelligence, an example, is some slides to help you understand a concrete example of artificial intelligence, which can seem almost magical to start with. But once you know how to do it, it gives you wonderful techniques that you can use in your own programming. So let me show you the programming question. So here it is. It's a program for playing noughts and crosses. It's written within the Turtle programming system. And again, I'll tell you how to get that shortly. If you load up the system and look in the menus, that's the example menus here, the noughts and crosses program is there. And you can see it's just over 120 lines long. So let's run the program and see what happens. Well, it's moved in the corner. You may know that I really have to move in the center or it'll beat me, or it can beat me. And sure enough, almost instantly, you can see it works out how to do so. If on the other hand, I move in the corner, it will almost instantly work out that it has to move in the middle. And now it will always avoid loss. So again, let me make a foolish move. You can see it immediately wins. So this is an infallible game of program of noughts and crosses. It will always win it if it can, and it will never lose. How does it work? Well, I haven't programmed it in such a way as to tell it what moves it should play in any individual position. If I click in the corner here, it is calculating every possible line of play that could happen from there and working out what is its best move on the basis of that. Now, the procedure which does that, which evaluates a position all the way to the end of play, is there. There you see it. That's it. So you can see it's not actually a very long procedure, and it's not a very complicated one either. By far the longest line there is that one. And all that's doing, actually, it's very simple. All it's doing is checking whether a line has already been made, either across the grid or down the grid or one of the diagonals. So here we have a procedure which is doing something really quite clever. If you look at the slides later in the handout, that explains how this works. So that's section 5. Section 6 of the handout deals with another problem that's related to Alan Turing, the so-called halting problem. So what Alan Turing did in 1936 was he came up with a sort of theoretical model of what a computer could be. We now call it a Turing machine. If you want to see a Turing machine in action, again, we can find one on the Turtle system. So here we go. Here's a simulator of a Turing machine. There we are. It takes a little bit of time because it's quite a complicated program. And if I choose one of those, there we are. That's a Turing machine in operation. You can see that it's generating a number here. I'm not going to attempt to explain that here, but just to let you know that if you want to go and explore Turing machines, you can follow up the resources on the philocomp.net website, and you will find those there. Okay, so Alan Turing invented the Turing machine. He claimed plausibly, he gave strong arguments for the claim that a Turing machine would be able to calculate anything at all that we know how to calculate. So take any solution to a problem that one human could explain to another in systematic terms. That could in principle be done by a Turing machine or a modern computer. But Turing also showed that there were some problems which couldn't be done by a Turing machine, cannot be done by a modern computer. And perhaps the simplest such example is the halting problem. And the slides there, slide 66 onwards, just a few slides, show, they prove that the halting problem is insoluble, which is quite an amazing result, really. You cannot write a computer program which will infallibly tell whether another computer program will or will not halt when it's run. Okay, so I've quickly mentioned the 3 topics on thinking machines. Let's now go back to the beginning and talk about computer science and philosophy. I'm going to run through this very quickly, but you'll see there are a lot of notes in the slides that I show. I'm not going to be reading them out, but you can get the handout and read them through for yourself. There's also lots of material on the degree program at those websites that I've pointed to there. One of them, as you see, is in the computer science department. The other one, philocomp.net, here it is. You can see it's a website devoted to computer science, philosophy, and the links between them. And if you go to this link here, Studying at Oxford, from the front page, that will take you to the various resources that I'm mentioning in this talk. And if you've got questions, you can email the computer science department at that address there. Okay, now computer science and philosophy, most people probably are quite surprised to find that there is such a degree program at Oxford. Many people are unaware of how intimate the connection is between those 2 subjects. And you may have come along thinking, well, maybe I'll try computer science, but computer science and philosophy, it seems a rather strange choice. Well, I hope to persuade you out of that. Think about what it is when you choose a degree program. What should you be going for? And I want to suggest that really top of the list should be something that interests you and something that you can be confident will continue to interest you for the next 3 or 4 years. And that's not as easy as you might think. When I came as a student to Oxford, I came to study maths originally. And I'd done 3 maths A-levels and physics. So I thought, yeah, maths is what I'm good at, maths is what I like. And it wasn't until I came to Oxford and I was surrounded by lots of other people who were good at maths that I realized that although at school I enjoyed maths because I didn't actually have to spend much time doing it, when I was engaged on a very intensive degree program, which really required something like 30 or 40 hours a week, I simply wasn't that interested in abstract mathematics. And on the contrary, I'd become interested in other things, in more philosophical things, things about life, the universe, and everything, partly because at university I was encountering people with very different points of view, and that was a very enriching experience. So there's a lot to be said for choosing a degree program that gives you lots of flexibility, so that if your interests change over the next 2, 3, 4 years, you can follow those interests and mold your degree program to fit your interests, rather than having to stick on rigid tram lines for 3 or 4 years. It's great to have a subject that's empowering, that's economically valuable. That clearly is true of computer science and philosophy. A couple of other points which again apply to both subjects. If you want to get to a top university in computer science or computer science and philosophy, you really need to be very good at maths. That's important for getting in, for getting through the aptitude test. And it's important once you're here because both sides of the subject require strong formal skills. In philosophy, for example, logic plays a big role. And if you're skilled at mathematics, you're likely to find formal logic much easier than those who are less mathematically skilled. So at school, you should be doing as much maths as you can. But apart from that, actually, it doesn't too much matter. It doesn't matter at all if you've not done computer science in the sixth form. It doesn't matter at all if you've not done philosophy in the sixth form. And in fact, most of the people who come to study computer science and philosophy have neither a computer science A-level nor a philosophy A-level. There's no disadvantage at all. Another perhaps much less well-known point is this. If you're thinking of computer science and philosophy at Oxford, then at other universities, you may well be thinking of straight computer science or straight philosophy, because not that many universities yet offer computer science and philosophy. And that might worry you, because you might think, I've only got one personal statement. What do I say? Actually, the answer is very straightforward. You address your personal statement to the other universities, the ones where you're applying for straight computer science or straight philosophy or whatever it might be. As far as Oxford's concerned, your personal statement really doesn't matter that much. Because you see, if you get through our aptitude test, then we're going to invite you for interview, whatever your personal statement says, more or less. And when we interview you, we will get a chance to ask you about your interest in the subject. So the personal statement becomes irrelevant. So don't let the personal statement issue worry you at all. There's some details about the standard conditional offer. Again, it's all on the website. It's the same offer as for straight computer science. There's a slide saying a little bit about what computer science is. I'm not going to say much on that here, because at the open day, I know there are a lot of talks devoted to computer science, and I'm focusing more on the links with philosophy. Be aware that there are quite a wide range of different areas in computer science. So computer science alone has quite a lot of variety, and some obvious reasons in favor of studying computer science. Computers are shaping the world. They will shape the future even more. Being able to understand and use and write systems for computers is personally empowering, gives you a lot of creative potential, and it's very valuable in employment. Another point is that computing employment tends to be relatively flexible. It's easier to work from home, to work from abroad, to take career breaks, and even to develop your own company, if that's your aspiration. So computing skills are very valuable in the workplace, very valuable to a lot of employers. Why might you want to add philosophy to the mix? Well, first of all, perhaps a bit of reassurance. If you are good at maths, then you're very likely to be good at philosophy. There's a large overlap in the sort of problem-solving skills involved in maths and computing and philosophy. And I've said a little bit about that there. It's all to do with decomposing problems in logical ways and being able to think through problems systematically. But of course, philosophy brings other things. If you are studying computer science and you add philosophy, then you get an entree into a huge range of interesting problems. And I've just listed a few of them here. You can see they go cover a very, very wide range of different topics, and very interesting topics as well. Will you enjoy philosophy? Will you find it interesting? Well, the best way to find out is probably to dip your toe in the water, take a look at some of the excellent philosophy resources there are on the web. Again, you can go to philocomp.net to find some of those. In particular, I strongly recommend Stephen Law's book, The Philosophy Gym, which I've pictured here. It's got 25 short chapters going through 25 really interesting issues. At least I'll be very surprised if you don't find some of them very interesting indeed. And if you do, that indicates that philosophy would be a good thing for you to study. If you'd like to sample some of the lectures that happen in Oxford in philosophy, I used to lecture in general philosophy. I did that for 13 years. And my 2018 general philosophy lectures are available as a podcast, as you see. Go and look at those. These were the lectures that took place in the first term of the first year, introducing philosophy to new students at Oxford. And again, if you find those interesting, then that suggests you'll probably enjoy studying philosophy. Again, that link and others are available from philocomp.net. That's the page I indicated earlier. One point about joint honours. And you, again, if you've mainly studied sciences at school, you may be a little bit apprehensive about working on something like philosophy, which seems very different. But actually, many people find that the variety is great. It's such a nice contrast to be sometimes working on problems which are very precise, analytical, where you can solve them within a short time, and problems that are much deeper and more difficult, more the life, the universe, and everything, and so forth. I very much enjoy that contrast, and I know a lot of my students do. And one very important point, this might almost be a note to my past self. I know when I changed subject from maths to maths and philosophy, I was very anxious about essays because I hadn't enjoyed writing essays at school at all. But all I'll say is writing philosophy essays is very different. Really, it's spelling out your reasoning, thinking systematically through a difficult problem, but an interesting problem, and putting down your thought processes on paper. It's the only realistic way of tackling a difficult problem. You have to write down your working, if it's in, whether it's in arithmetic or computing or philosophy. But in philosophy, of course, you're using the English language to do it. And it's a great skill to acquire, really valuable. When you get into the workplace, if you come out with a degree in computer science and philosophy, you will have developed skills that most computer scientists do not develop, skills in written and spoken language. And those are skills that are hugely important in the workplace. And I've noted there some of the advantages they bring. But you don't need to take my word for it. Here is a quotation from the Oxford Computer Science External Advisory Board. So these are employers saying the value that they see in computer science and philosophy. They see the graduates who come out with this degree as having tremendous potential, not only in technical areas, but actually rising to the top of companies and helping to direct their future direction. Because these people will have the kinds of skills that are needed: persuasion, argument, discussion, seeing something from somebody else's point of view, synthesizing a case, thinking through wider implications, the kind of thing that philosophy brings you. On a personal note, when I started the degree in computer science and philosophy, when I set it up, well, one of my real main ambitions was to develop young people who had skills that the world needs. I've listed there at the top some of the problems that my generation is bequeathing to your generation. And I'm sorry, we've really made a bit of a hash of it. We haven't really got into seriously addressing many of these. And of course, there are, in recent years, with the development of artificial intelligence, there are a whole lot more new problems that have come along, and I've listed some of those below. The problems that artificial intelligence brings actually were explored in a podcast series that I've been doing. We had a season on AI last academic year, and I found it really fascinating and learned a lot from it. So there were 10 episodes where I was usually interviewing 3 academics from across Oxford, typically researchers doing technical AI research or research that was related to AI in the social sciences and so on, talking through the sorts of problems that artificial intelligence brings for the modern world. The graph here was from one of those talks. It included Mike Osborne, who wrote a very influential paper suggesting that 47% of United States employment was liable to be taken over by machines within a relatively short time scale. Just think of the implications that would have, the disruptive implications for society if anything like 50% of jobs were just to disappear. I'm glad to say the discussion wasn't as pessimistic as that makes it sound. But I hope that if you go and listen to the Future Makers podcast, you will appreciate some of these difficulties, how fascinating they are, and how important it is to address them. Well, your generation, if it's going to succeed in solving this multitude of problems, you're going to have to make artificial intelligence part of the solution, not just part of the problem. We need talented young people who understand the technical issues, but are also able to address these in a wider context, to actually bring some workable solutions that can fit with the social, political, economic, moral structures of the world. And I can't think of anything better than a degree in computer science and philosophy at Oxford to equip you for that. Final point about the degree, it's extremely flexible. In the first year, as you can see, the vast majority of the course fits perfectly into a computer science degree. Elements of deductive logic is logic. Alan Turing on computability and intelligence is computational theory alongside Alan Turing. And general philosophy, the lectures I pointed to earlier, that's the only part really that would look out of place in a straight computer science degree. From then on, you can see it's 50-50 in the second year. In the third year, you can move very strongly towards computer science or philosophy if you wish. And in the fourth year, which is optional, you can do 100% in one subject or the other if you like. So if you start out doing computer science and philosophy and you decide in the end that you want to max out on computer science, you can actually spend 80% of your degree doing computer science. And even the philosophy bits that you do could be things like philosophical logic, philosophy of cognitive science, philosophy of logic and language, things that are actually very closely allied with computer science. On the other hand, if you take an interest in other areas, you could do, say, ethics, political theory, philosophy of religion, history of philosophy. There's huge variety. And the philosophy faculty, it's the biggest in the world. You've got massive choice. So it's very unlikely if you take computer science and philosophy that you're going to run out of things to interest you. Very quickly then, moving on to the second section of the slides, just highlighting some of the links between computer science and philosophy. Again, there's lots more on the site philocomp.net. That was really devoted to setting out these links. I put the site together when I was making the case for the joint degree. But you can see a lot along these links. There's lots and lots and lots of connections. Some obvious big ones: logic is central to both computer science and philosophy, and taught in the first year of both. Artificial intelligence. Well, there's a huge amount of philosophical interest in artificial intelligence, not surprisingly. Artificial intelligence raises all sorts of questions about the nature of our intelligence, our agency, what it is to think as a human and as a computer. There are lots of moral issues. I've already mentioned that some of those have been intensified by the development of artificial intelligence. But there's questions about how should we make robots behave? Obvious moral questions arise there. Issues about privacy, about security, about autonomous weapons, autonomous cars, and so forth. But actually, there are loads of other connections too. In almost any area of philosophy, the development of artificial intelligence raises new questions. And there's a huge number of areas of computer science which border on big philosophical questions. The reason the connections are so deep between computer science and philosophy is that philosophers are particularly keen on rational thinking and systematizing what it is to be rational. And from that point of view, you can see the computer as actually realizing the philosopher's dream of automating reasoning. One way I like to think about this is as the computer as a prosthesis to my mind. So in exactly the same way as this man has a prosthesis to his leg, which enables him to do things that he wouldn't be able to do without it. So by having a computer as an assistant, by being able to write programs, that empowers me by enabling me to solve problems that I just would not be able to do by other means. And that gives rise to a new form of investigation where we use computer models to explore interesting ideas or theories, which may be about just about anything. I'm going to point you here to some resources. Some of the things those resources cover include mathematical exploration. So here you've got pictures that come from computer programs that are on the Turtle website. The programs there, so there's the address. As you see, have examples also from chemistry, biology, physics, and other areas. Some of the programs explore the creation of natural patterns, like some of those you see here. And down at the bottom right here, we've got a program which is actually modeling the spread of disease. Now, I haven't got time to show you this in any detail, but just very quickly, let's take a look. So here we've got a program that's modeling an epidemic. You can see the epidemic is spreading. A number of the individuals here are immune to the disease. They're shown in blue. The red ones are infected, and you can see they're spreading it. So one of the interesting things you can do with this model is see what happens if we start out with 10% of the population being inoculated, so that instead of only 2% being naturally immune, instead 12% are naturally immune. And the dynamics of the disease change hugely. Now, I haven't got time to show that in any detail. If you go to philocomp.net, I'm putting another talk there in which I do talk about the dynamics of disease, obviously particularly pertinent at the moment. And for example, can show the tremendous benefit that one gets from locking down on movement during an epidemic. Okay, I'm going to finish with this example. Imagine that that's a city. It's a city in which most of the blocks are inhabited either by people of the red persuasion or the blue persuasion. And let's suppose the reds and the blues are two different religious groups. Some of the blocks, as you see, are green. That means they're currently unoccupied. Now you can imagine that a politician looking at a map like that and seeing the reds and the blues so segregated would very likely assume that the reds and the blues really dislike each other. So I'm going to show you a simple computer model which explains why that politician would actually be making a serious mistake. In other words, you can get segregation like that, even if the reds and the blues don't hate each other at all. So here's how the computer model that I'm going to show you works. Let's suppose that I'm a red. Here's me on the left here. And let's suppose that I have, in this case, 7 neighbors, 4 of them are blue, and 3 of them are red. Now, in general, it's unsurprising if I prefer being with other reds. Reds, they've been to the same schools, they go to the same religious ceremonies, they have the same holidays, they sing the same songs, they understand the same jokes. So in general, probably I will get on better with other reds than with blues. But what you can see here is that in this situation where I have 4 blue neighbors and 3 red neighbors, I'm perfectly happy. That's fine. So I'm not a virulent anti-blue. I just have a mild preference for reds. And if we go to the situation on the right here, where I've got 5 blue neighbors and only 3 red neighbors, so the blues are outnumbering the reds now by 2 or more, let's suppose then I will be unhappy and I'll try to move. So I've got a slight preference in favor of being with those of my own color. But it's not a huge preference. I can quite happily tolerate having 1 extra neighbor of the opposite color, but not more than that. So let's see what happens if we run a model in which we start out with a completely integrated city like that. But every individual within that city operates in the way that I've just described. It's really quite shocking that we end up with almost complete segregation. The problem is we get a sort of cascade effect. If a red is unhappy and they move from a predominantly blue area to a predominantly red area, they're making the blue area more blue and the red area more red. That's interesting. This is an unusual case where we've not gone all the way to complete segregation. That's very surprising. I would say 19 times out of 20, we end up with complete segregation. There's an element of randomness, so it's different every time. So this is just an illustration of how a computer model can shed real light on a practical problem. Here, a problem of social design, and you can see that it delivers a very surprising result. Well, there are lots and lots of other examples to look at. I've got to end there, but I hope that you will go and look at philocomp.net, follow some of the links from this Studying at Oxford page, and I hope very much that having looked at those, you might consider seriously studying computer science and philosophy at Oxford. Thanks very much. Goodbye.